I like models of computation. I like to find a really simple way to do stuff that was difficult the day before because you didn't have the right model of computation. And for the past few years, actually, I've been thinking about things like this. Everything from regexes, which I will be talking about in 60 or so minutes, to observers and event models and so on. So this talk is mainly about sharing a bit of that. And it starts at a kind of a weird angle. I made a tweet a couple of years back. Sort of, in my mind, I imagine it as being in the middle of the night, sort of sleepless, suddenly realizing that, oh, at some point I'm going to make a robot. It's just inevitable in all of my possible futures. I'm going to stand there putting together a robot from constituent parts. And you know, robots are in this nice intersection between fantasy and actual everyday life. We have this nagging feeling that they will come into our quite near future and sort of help us with boring household tasks, or maybe even drive our cars, watch our children.
Bring us beer.
Bring us beer. I forgot almost the most important part. Yeah, you see, there are endless possibilities here. And robots already, before they really exist in our everyday life, they have this kind of cultural thing about them. It's almost like pirates or zombies. Robots, they just are. And so I'm building an IRC utility bot. I'm realizing the physical limitations here. It's 2013, that's far into the future. However, I can't just go out and get me parts and it will be a useful bot. But there are a number of useful things I can do with an IRC solution. An IRC would simply be the tip of the iceberg. It would really be sort of a giant data storage for helping move it with everyday stuff. So sort of kind of an online secretary. The name I have for this bot right now, which is a working name, is the Chinese word mishu. Jonathan keeps teasing me about it because it sounds like Patrick Michaud. Like I would have him for the secretary. That would be a real waste of skill, actually. But no, Mishu is a kind of appropriate name because, as in so many languages, it means sort of writer of secrets. It's an interesting linguistic fact that whatever language you pick almost, secretary, the word secretary has something to do with secrets. It's sort of the boss as a keeper of secrets. Do we have any Ukrainian people in the audience? What are the words for secret and secretary? That sounded similar. It sounded like one was based on the other. I don't know which direction. Yeah. So you see, and it goes for other weird languages also, even Hungarian. So I would like something like this. I hope you can read this. This is a simulated IRC conversation, a reminder function. This is actually the function that works so far. I unfortunately probably won't have the internet connection to show you. But you go remind, and then how many minutes, and then what you want to be reminded about. And the bot just say, okay, reminder added, and then time passes. You're disconnected from the flow. You can go forget about the whole reminder, which is kind of the point, really. And then you're reminded.
Well, just a second. It's possible for you to stand there because you keep them blocking the sliding.
Oh, definitely. Where will I stand so I don't block anyone? Here? This is much better, yeah.
Back there.
I could go with it.
It's the voice from the off.
So, reminder function. The big important thing here is the disconnect. You have offloaded from your brain something you need to remember. So the IRC bot acts as a kind of remember all here, except it actually tells you what you forgot. Remind about people's birthdays, for example. So here's another example, just at birthday. I don't even have to say remind me about birthdays, because it does that for every date that's added as a birthday. Here the example is for my sister, Emma. I'm not implying in any way that I would ever forget my sister's birthday. It's just an example. And then the 10th of April rolls around and voila, it reminds me of my birthday. Here we actually have another kind of timing problem which I've been mulling about, and suggestions appreciated for that. I almost never want to be reminded at 12 o'clock midnight about people's birthdays. Usually on a sort of normal working day, obviously. So that's yet another delay, sort of. It will remind me when I wake up sometime around 7. By the way, a short note about syntax. I could have gone wild here with language parsing and things like that, you know. Say, actually, that the birthday of my sister Emma is this and this date. And it could do a great job of actually parsing out the sentence and constructing the equivalent of a function call and doing things in the background. However, for once I realized that I shouldn't encourage scope creep. I shouldn't work on the things that I'm actually not interested in for this. So I just keep the conversation with this bot very, very simple. Keep it to a minimum. Try to stay close to some abstract Perl-like or JavaScript-like syntax, and that will be what the robot understands. If for some reason in the future I change my mind about this, I can always add a language parsing layer about this. I don't know, maybe in 2020 we will completely have solved the language parsing problem.
Can I ask you a question? If you add,
Yes.
if you say now afterwards add birthday for another date because you mistyped, will it modify or do you get a double record? I hope not.
Probably it would at least query me and say, hey, you typed this in already.
Yeah.
Maybe there will be an add birthday and a change birthday, something like that. I agree that it just shouldn't swallow it and accept it.
Unless there's more than one person in the world called Emma.
Oh,
Unlikely, very unlikely.
Then we get into the sort of identifier problem. Usually I have short identifiers, especially for family members. I think of them as Emma. It's not sort of Emma Mäsak or anything like that. That's not the symbol in my head. And sometimes the same person will have several symbols and so on. So you see how a personal database will quickly run into sort of multiplication of different layers of problems. This is not even what I'm going to talk about in this talk. Still interesting. Then I have a problem of simply keeping track of all my, how do you pronounce it, gists with a soft G? All my gists, yes. They are gists on GitHub, very low. So, gists lack a tagging system, and at this point I have thousands of them. Hundreds that I don't care about, but dozens that are kind of important, and I see myself just wasting a lot of time trawling through all this gist in reverse chronological order, clicking the next thing, and sort of my life is withering away, and all it would take would be a simple index, and the robot could keep this index and report it to me. So just search for something. So these are 3 simple, realizable dreams that could be fed into this, basically a database, and then something on top of it that stores and retrieves information, and also has this ability to come back to me later with stuff, because that's really the important thing. That's where IRC comes in. Someone can come and tell me stuff, and it's my perfect secretary who just happens to be a machine. Oh, a 4th example here. My schedule, and probably birthdays really would fall into a schedule-like thing as well, because sometimes it's too late to be reminded about some person's birthday on that day. But, like if you're going out to get a present or something. So, the next 2 weeks in some simple ASCII-like format, all the way I'm trying to sort of keep it low level and low tech and just solve the problem in the shortest possible way. So, to build what I wanted, I needed to sort of go to the drawing board and think about the underlying model here. But yeah, I know I want a data store to store all the birthdays and all the schedule things and all the index to the gist and so on. But I also need something that's fairly reactive, that's fairly asynchronous with everything. I like to keep it simple, Simon programming principle. Yeah, I say Simon. I don't know if the camera's on. You don't know what you leave behind on the internet. Reduce everything to its bare minimum. If you go to Spike Solution on the wiki-web, you will see a bank account implementation in 1 line of small talk. That's always inspired me. And they were doing a hackathon, and someone said, well, wait a minute, can you add this function? And they sort of added half a line more, and they had that function. So most of the things we program is craft, and we don't really have to have it. It's sort of things that connect together, parts of subsystems and so on. But somewhere there is or should be a core of the actual problem that you want to solve. And we need some kind of core here as well, something that will drive the bot all the way to all the present and future functionality that it will have. So, yes, here's the actual definition of this. So for a long time I thought I should use events as my model. Now events is this excellent idea that you don't really store data as the primary thing. You only store all the things that have ever happened to your model. So add birthday is an event. Or modify schedule, or put this thing in my schedule is another event. And computers are so fast these days that if you ever want to talk about the present state, you just replay everything. And you can chunk things into different aggregates or something. So birthday is one aggregate. So it's not even many things you have to replay. So this was a running model that I learned about a couple of years ago, and it seemed like the least bad for this kind of bot. But there was something that wasn't exactly right about that. So, and you probably heard about events in, for example, GUI programming. That's where people tend to see them. This is similar but different in the sense that it has nothing to do with the GUI. We issue events about everything that happens in the data model. So event-based programming seemed like a good idea for a long time for me, but I had in the back of the head that there's something not quite right. And in such a system, the program logic would consume events or produce events, and basically all the components would be sort of event producers and consumers in this way. Something that produces an event, for example, would be one of these command handlers. At birthday, it sends away an event, and all the other parts of the system listen to that. But I couldn't exactly see how it would work, and that made me a bit sad because I liked the event model. Especially, how would I get around sort of adding some kind of workflowy function if I actually wanted some kind of dialogue with this bot? And that's something that could occur over time, sort of like, yeah, I want to book this hotel and blah, 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 what do you blah, 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 back and forth. And doing that with events would create a very scattered kind of system. I would have very small subroutines that just delegate to each other, and it would be hard to get an overview of the system and hard to modify it afterwards. So that was something that was not quite right there. So events probably weren't for me. What I really needed was reactive programming, something that I opened my eyes to earlier this year. So this talk really is about reactive programming. What you heard up until now is just a preamble. Reactive programming, but not quite yet. Hold on. We'll get back to this. Let's just put it some kind of continuation or delay here and get back to that. So in order to talk about that, let's start at Perl 6 and lazy lists. So I want to bring some kind of foundation to this. Lazy lists are awesome. They are in Perl 6. It's like we looked at iterators and lazy lists and just said, yeah, let's do that everywhere because it's a really good idea. I've been so soaked in the Perl 6 thinking that I once downloaded a Perl 5 module for doing combinations of things. So you have ABC or CBA or BAC or all possible permutations of things. And I entered something ridiculous like 20 different letters and just hit enter and expected it to start larping out letters. Nothing happened. It was only after like 15-20 seconds that I realized, all right, lazy lists are not native to Perl 5. You would have to implement them yourself, and this module probably doesn't. If I could find it again after that, I would say what the name of the module was, but I haven't found it actually. All the examples I found now actually do lazy lists, which is really good. So here's what we can do. We can sort of defer back and forth between different program calls. Here we have a lazy list being constructed, up here with a gather, and you see it it puts things into the list with this take instruction, but between that, it prints 0 and 1, sort of in between. And if you just do this, nothing happens. Nothing gets set. This is the lazy part. It hasn't run yet because you haven't needed the values from the list.
Question?
Yes?
Yeah. Sorry, any chance to magnify the screen or
There is.
actually
There are 3 chairs at the front row.
Yes, please move forward if this poses eyesight challenges. Oh, that's much better.
Yeah, yeah.
Thank you. Thank you, Marco. So, the actual code isn't run until after we start pulling values out of this list. So we say number 0, and only then does 0 get printed. But then it pauses again. So after the take 0 here, it's like some programming instruction is up here. And it doesn't go past that until we ask for the second value. So it's like in our program we have a producer-consumer relation here. And what's lazy is the producer does as little work as it can get away with. It only does the work that we ask for. It even remembers the previous value. So if you ask for lazy 0 now again after this program, it will not print 0 because it's stored it away until if for some reason you need it later. So this is lazy list. The producer is lazy and the consumer just calls things when it needs it. The best thing, these things can be combined. And they can be combined with mostly things that we already know from Perl 5. So that's why the model fits very, very well on what we already have in Perl 5. So map and graph are lazy by default. If you put in a lazy list, you get out a lazy list. So now you can construct something that's also lazy, that doesn't do more work than you asked for. We have list multiplication. If you're wondering why there are 2 x's, we've actually separated out the string multiplication and the list multiplication Perl 6. We also have lines, for example, when reading from a file. It's lazy or supposed to be lazy, I think there's a recruiter bug, where it actually doesn't consume more of the file than you ask for. And then something as simple as post-circumfix or brackets, like you saw here on the last slide, where you ask for something, that's also lazy. So it doesn't consume the list more than it has to. We also add a few of our own that are not present in Perl 6. For example, you can cross together 2 lists. That's like multiplying them together, so you get a big table of combinations. Here you get a list of comma pairs. So if you have 1, 2, 3, A, B, C, you get 1A, 1B, 1C, and so on. 9 different combinations. Then we can zip together 2 lists as well. So you just take them pairwise and combine them. And all of these are combination operators to build bigger and more useful things. And then we have the general sequence, which also is lazy. You can make it start at 1 and just count upwards to infinity, and it will not hang unless you specifically ask it to pull out all the elements, which you shouldn't do. A quick demo about this, because it's so nice. So here's an infinite sequence, right? We say take the first 20 values. Yay, there they are. And, oops. And this takes a very long time. You can also do so A plus B and 20. The same Fibonacci sequence. Just saying, yeah, 1 and 1, and then we just go on by summing the last 2 values. This is actually easier than that in PAL6 because we can just use 2 stars for this A and B variable. Ellipsis, thank you. Start copying code.
Comma before the 3 dots.
Missing comma.
No, I don't think so. The 3 dots are the operators, so they're not missing a comma. I had 1 comma too much at some point. Or you could just say use the pre-existing infix plus operator, that also works. Infix plus. So just use plus up to infinity. And you know, somewhere along the way, we are holding an infinite list, we're just not triggering. We're not pulling out all the values, because if we do, we hang. So lazy lists are nice because the producer doesn't block. It just does a little work each time you call .next. But 6 is nice because you will write normal code, you have this take function, and it actually transfers flow back and forth. And that's really, really nice. It makes you able to write more readable code, and it looks like a normal thing when flow goes somewhere else. This is such an innovation that there is a problem in computer science called the same fringe problem, and people have been trying to solve in various programming languages how to actually compare these 2 trees. And we want to say that they are equal in some sense. We have A, B, and C here, and A, B, and C there, and the tree structures are different, but if you traverse them and you go down into the leaves in infix order, you will find the A, B, and C in the same order. And this used to be a tricky problem in programming history because you were solving 2 problems at the same time. You were traversing the tree, and you were building up a list of these leaves that you found along the way. In PAL6, it's pretty trivial. You just nest these 2 things. You iterate through the trees, and then you compare them along the way. If at some point you find 2 things that are not the same, you can abort. You don't need to pull in more material. You can stop sort of in the middle of traversing the trees, and you're done. That's the power and the beauty of lazy lists. Which brings us back to reactive. Now we have enough material to reactive programming. So a lazy list is a sequence of values, and the producer can relax and not block so much. That's nice for the producer. In comparison, an observable is a sequence of values, and the consumer can relax and not block so much. Why is this nice? Well, often in code, especially when you're using library code and so on, we are the consumer. We want to relax and not block so much. This is what event programming and web services and so on are all about. When you use asynchronous things, you do not block. You can continue working. Your GUI doesn't freeze up all of a sudden. So remember this use case, I have the reminder function, it adds a reminder, and I do not block it, neither as a person or the program doesn't block, so things can happen in between. If I had a reminder in between, it happens in between. So things are decoupled between sort of adding the reminder and pulling it out again. We do other things, and we just trust that we get notified. So I have this example. Listening to mouse events to draw a line. This is an actual PAL5 module to do reactive programming. And here you see we're using something called an observable, which is something that produces values, but not when we ask for them to be pulled out, but whenever they feel like appearing. Here they are coming from the mouse, when the mouse is pressed and released. So the user triggering mouse presses and releases is what will be activating these observable values here. And then we combine them. So we use exactly the same kind of abstractions that we use for lazy lists. We use map here and on shift and combine latest, and here's grep as well. And we can take these simple observables and build better and nicer observables that do exactly what we want. So by the end here, we have a sketch producer that produces just the combination of mouse clicks that we care about. Sort of pushing down the mouse button somewhere, drawing the mouse over to there, and releasing it. So that's exactly what we need in sort of a drawing program to indicate drawing a line, for example. And finally, now the sketch variable that we combine together like this is exactly what we want. We just subscribe to the stream of values and add logic to it. So things are very, very decoupled here. This would be the consumer in this situation. And the consumer doesn't say, hey, I need the next value. It says, I want to subscribe to your newsletter. Next time you have a value, just let me know and I'll do this. So, and this is the nice thing, comparing lazy and reactive, we're kind of seeing a pattern here between them. They are similar but opposite in a very well-defined way. What we do with lazy is basically three different things. We can return the next value. Sometimes there's an error that happens when we try to return the next value, or sometimes the list simply finishes. Not all lazy lists are infinite, and we just end the stream of values normally. Now, on the reactive side, we do all those things, but we do them by listening instead of by talking. So we have an onNext method that we can use when we subscribe. We have an onError method that we fill with logic, and we have an onCompleted method. This is called duality, by the way. So lazy lists and reactive programming are duals in the category theoretical sense. And this is such a deep insight that it wasn't discovered until a couple of years ago. So you go back and look into your Gang of 4 book with design patterns, and it's not there. You have iterator as a pattern, and you have observer as a pattern, and it's not mentioned at all that they're related in this kind of neat way. The big problem with laziness is still blocking. Like we ask, okay, what's the next value in the infinite list? And we totally block because some computation happened that never finishes, or it involved a web service call that simply didn't get back or simply didn't succeed. So the producer does something heavy and the whole program comes to a halt. As we make bigger and bigger programs out of small parts, and we're seeing this in GUI programming and web programming, this becomes increasingly a problem. We need the reactive solution to keep our things separated and keep things from not hanging. Now the big problem with the reactive is, I would say, you can say, oh, come back to me whenever this interesting thing happens that I'm interested in. And the observer says, okay, and then nothing at all happens.
Sounds like a lazy observer.
It's a really lazy observer sometimes. No, it's actually the opposite problem of laziness. The problem of laziness is too much blocking, and the problem of observers is nothing may happen. You may go out to infinity, and you simply never hear back. This is a problem for my bot as well. How will I know if something is wrong, for example? Or how will I know if too much time passed for some event or something? Maybe these discussion workflows I'm imagining shouldn't go on for hours, just a couple of minutes. Yes, yeah.
Do you understand reactive right, that it's kind of callback? You're registering callbacks.
Yes.
But you said they're equivalent. If you take the same fringe problem, you can solve it with a lazy method, but not with a reactive method with callbacks.
That's true. No, I didn't say that lazy and reactive are equivalent. I said that they are duals in the sense that you've turned around all arrows.
Okay.
So telling someone something becomes listening to something instead. I could see a reactive programming to same fringe, but it seems kind of strange to apply that solution. So yeah, I would go.
We had this discussion on Belmont some weeks ago.
Oh, wonderful. Please point me to it. Anyway, the solution is more reactive events. We simply introduce a timeout saying that if nothing has happened until now, at least this thing happened, at least this timeout triggers. And the clock becomes an observable as well. It sort of fits into this model, saying, yeah, okay, we trigger there and then if something has not happened until now. Some dreaming about this. The goal is, just like with Gather, to write all the code in one place. That was the nice thing with Gather, that I could do take and it would just skip out of the flow, the running flow, and come back later when it needed to, lazy. This is what I want with observables as well. I do not want small, tiny subroutines all calling each other through observables in a way that is very hard to debug and very hard to track. Most of the time I just want to write my normal if statements and while loops and write everything as a single story. This is how I tend to want to program. I don't have a solution to this, except for very heavyweight things like continuation passing transforms or things like that, which involve knowing what the compiler does and will do. Thank you. We also have a nice benefit here with testability. What's driving this underneath? We need to have something that sort of controls all the observables and tells observables and subscribers about each other and so on. And that's called a scheduler. And it instruments everything. It's the puppet master that holds everything together here. And they call the appropriate method. So if you define one of these one next methods, the scheduler is what eventually will notify it about this. And this is excellent for testing because usually we don't have control over the entire external environment and people use dependency injection and so on. Here we can just dependency inject the scheduler and we're done. Then we control the environment, then we are the reactive god of our program. So you can control time, you can control the environment. If you want to test that something happens 5 years later, your test doesn't have to wait 5 years, you just set the clock. You can even test that something happens 5 minutes earlier, but I wouldn't recommend that. It's possible. Here we would have the live demo. Unfortunately, I don't believe at all that we have a network connection. Let's try again.
Try FC5.
I was recommended to try FC5. And it's Kiev. Well, I probably shouldn't say this out loud because it's so secret. Can it be true? We're connected. Okay, so restarting this one. Oh, look at that. It'll be terribly slow, but it looks like we have a chance. And according to my watch, we have 7 minutes to do it. There we go. Yes, this is part 5. Oh, it's fantastic. Don't know if I should get any output here, but I definitely should see a bot turn up. Should we look at the source code while it decides to enter the room? It's really not much. So yeah, typical post source code, enter visual test here, and where are our reminders? So we have the remind function here, and then yeah. New. I think it may have trouble connecting. Environment. Right, there we go. So here's what happened. We match against this simple regular expression remind, and if that matches, we just call into this remind. And it all uses this event passing system, which for the purposes of this connection refused. Okay. Do we have any questions?
Oh, I have one.
Oh, go on.
The lazy lists, are those in any way different from generators?
Now there is some terminology here.
Repeat the question.
The lazy lists, are they in any way different from generators? I've looked into the difference between iterators and generators in Python recently, and it seems that an iterator is something that a list has, and a generator wraps around that, right?
Yes.
And
Turn something into a generator. It's basically a coroutine.
right. So I would say the closest thing you have to a generator is the gather construct. Thank you. In POSIX. And the gather construct is kind of special. You know, in most languages you have functions and then you have yield. For example, in Perl or Ruby or .NET. It's still trying. Nice. And here it is. Hold on. I'll keep answering. Just putting pause on that one. One.
Set your reminder to answer the question.
So that's one end of it. So while I answer the question, just doing this in the background, very appropriate. Now, gather blocks are totally decoupled from functions. So you don't yield out a function, you just take out of the gather. And it's not at all connected to sort of calling functions and being inside of functions. So it's a completely decoupled mechanism. But it does work with functions as well. So you can be several nested functions down inside of a gather, or dynamically, you can still do take that. So the take is dynamic. That's very useful when you're recursing on trees and things like that. Has it been 1 minute yet? That felt like 1 minute, but it always does, doesn't it? Maybe 1 minute is longer when we have network problems. Any other questions? Yes.
It's not a question, it's just pointing to the further question before. It's what is the site? There's a site which compares different approaches to different languages to same problem. It's
Rosetta code?
Exactly, and they have same fringe.
Yes.
And there you can see how they did it with Perl 6 with gather take, where you have where the gather block calls nested functions, and in these nested functions, which are not gather blocks, you have a take expression which goes back. You can't do this in Python with generators because you need to do the yield in the generator itself. You can't call a subfunction from the generator and then the subfunction does the yield.
That's why we made it orthogonal from
Right.
everything else.
That's why it's decoupled from functions. Let's see if we just finish up here by watching the POSIX solution. That's very good idea to mention. So we find the fringe here. And that's the one that iterates down the tree. It simply does a gather, and for leaves it does a take, and for not leaves it recurses down with two multisubs, so it can sort of dispatch on whether it's a leaf or not. And then the same fringe solution is just saying iterate on A, iterate on B, check if they are deeply equivalent, and that's it. And with that, I think I'm out of time.
No.
I have 2 minutes, so we can squeeze in one more question. And then unfortunately I have to rush off to the very same room to give another talk. There appear to be no more questions, so I'll just say thank you for your patience.